Orlando Solis from Advanced Quantitative Reasoning. We're going to go over something called Kruskul algorithm. So right here, according to this is what you do. You take a table just like this, and it assumes that we have a table. And so we're going to be graphing this. This is connecting several islands on this bunch. It's something like a whole bunch of islands. There's a total of 5 of them: A, B, C, D, E, F, and G. We're going to connect them all, and we're going to go ahead and use the lowest amount of money to go ahead and connect them all. So this is what Kruskul's algorithm says. Put all weights in a list from smallest to largest. Now, I understand you guys can do that by hand. It's really easy. In fact, the smallest one right here is 3, and next is 4, and you can go on from there. But with me, since I'm a little bit handicapped in that thing, I've gotten my calculator to do it. And so this is what I do. I enter in all the weights into my calculator just like this. And I just put them in one big long list. And this is under L1 right now. Now I'm going to go ahead and sort it. So I go to Stats. Then I find where it says Sort A. This means sort ascending. It goes from the smallest to the largest. Then I hit second 1. And that brings up L1. I'm going to hit enter, and it says done. Now the great thing about this, when I go back into my list, it's all in order from least to greatest. So I'm going to start with 3. Well, actually, before I start this, I'm going to go ahead and do this. I'm going to go ahead and mark all of my points. I'm going to make a whole bunch of points. So this starts with A, B, C, D, E, and F. Now, I really don't need to care about what they look like or what have they, as long as I get them connected and get all my weights. So, I might have to use a pencil to go ahead and correct any mistakes I might make, but I don't think I will. So right here, so when you do this, I would be using a pencil. So let's see, find the smallest weight in the list, and include the associated edge and 2 vertices, as long as that does not create a cycle. What that means is that we don't want it to go back. We don't want to go ahead and have something like, all right, we have these 3 things, and we have them all connected like that. We don't want a cycle. We don't want a loop. We don't want to loop back. So right now we just want to connect them all in one graph. So now we have the smallest number, which is 3. That connects island B and F. So B and F are best friends now, and this is 3. That's a weight of 3. And that didn't create a cycle. It's still a path. It's good. Then we go to, let's see, the next one, which is 4, which is B and C. So B and C also get connected, and that has a weight of 4. The next one on our list is 5, and we find it right here. We have island F and C. So F and C, if we connect that, we'll make a cycle. So we don't want to use that one. This is bad. This is a bad one. Bad. Very bad. Okay, so we go to the next one. So the next number in our group is, after 5, is 6. And actually we have 2 6s. So let's see, where are 6s? Where are the 6s? So far we have all these connected. We have 6. This is our first 6. And here's our second 6. So we have island F and E, or island G and D. So F and E get connected. So let's go ahead and connect those. It's not going to create a cycle, so it's good. So that's 6. And D and G also get connected. Ooh, I forgot to put G. Sorry. So I'm going to just connect them, and I'm going to keep it out of the way, so I'm going to go ahead and loop it around. Just go ahead and connect it like that. It doesn't matter how we go ahead and connect them as long as they get connected. So it has a weight of 6. Now, we need to be able to get this one connected over here, but that's all right. We'll figure it out as we go. So that goes ahead and gets rid of that and that. So 6. Next is 7. So we have 2 7s, so 7 and 7. So E and A get connected, and actually that's a good thing. And that's EA, which is going to be in the game. That's 7. Then we also have G and B. So GB. I'm going to go ahead and connect it like this. And that is a weight of, let me see, where is it? GB. Well, this is 7. That was also 7. And this is when we check. We don't have any cycles here. All of them are connected. So if I were to clean this up, I could get this a little bit cleaner. But I don't need to right now. So let's see. So if I were to go ahead and connect everything, A connects to E, and that makes A, well, A to E, 7. E to F would make 6. F to B is a 3. B to C is 4. And there's a reason why I put it off like that. B to G is 7. And G to D is 6. And they're all connected like that. So if you wanted to go ahead and graft it like that or that, however you want, it'll all work out. This right here works for me. If you want to go ahead and find out what the total cost of making these bridges or this set, it would be 7 plus 6 plus 3 plus 4 plus 7 plus 6. And that would be a total cost of 33. Alright, I'll see you guys later. Bye-bye.